up, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. See ya.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. In our lesson today, we are continuing with question 7 of the Limpopo June 2026 question paper. Itu, what is our question for today?
So then today we are doing 7.1.5. Says hence or otherwise solve for open bracket x minus 2 close bracket cubed minus 6 open bracket x minus 2 close bracket squared plus 9 open bracket x minus 2 close bracket is equal to 4.
Okay, how many marks this question?
This question is for 2 marks.
It's for 2 marks. Okay, guys, 2 marks means we shouldn't put that much effort, and then we're going to try to simplify it as best as we can. Remember, we're going to take the solution, put it in the senior marker. We're also going to be playing a song, explaining a little bit about hence. Once you see the word hence or otherwise, it means you should use one of the solutions that you've already solved. So that's what we're going to be doing. Now, the simplest way to do is to check what is it that you've already done. Now, if we can check from 7.1.2, we're told that we should calculate the x-intercept.
Yes.
And we're given that g of x.
Oh, it was f of x.
It was f of x.
Yeah.
Okay, f of x. We can tell them that we were given f of x
is x cubed.
It's x to the power of 3, yeah.
Minus 6x.
Minus 6x.
Squared. Minus 6x squared.
Yeah, okay. Yeah.
Plus 9x.
Plus 9x.
Minus 4x.
Minus 4x.
Minus 4, I mean. So to say.
Minus
4. Minus 4.
Yeah, it is today. Okay. So we have the following equation, and then we're supposed to calculate the x-intercept. Okay?
Yes.
How did we do that? We made our f of x to be 0.
Yes.
So we had something like this. Let's write it this way so that it will be similar. So we're going to have x cubed.
Yeah.
And then we have minus 6x squared.
Okay.
And then we have plus 9x.
Yes.
Minus 4.
Okay.
Equaling to 0.
Yeah.
And then we're supposed to solve this thing.
Yes.
When we solve this thing, eventually here's what we got. We got our answers as x is equaling to 1. Again.
Yes.
Or x is equaling to what? To 4.
Yes.
Still fine.
Yes, sir.
Now let's compare the new one that we have now. The new one that we have, it says open bracket.
Yes.
It says x minus 2. All cubed.
Yes.
And then it says minus 6 open bracket x minus 2 all squared.
Yes.
And then it says plus 9.
Plus 9 open bracket x plus minus 2
yeah,
is equal to 4.
Is equal to 4. Then we're going to take the 4 to the other side, and then we have minus 4 equaling to 0.
Yes.
Now we can just take our highlighters and just try to compare, yeah, to compare the two things. So we have equation number 1, and then we also have equation number 2. If you check the one that we already did, it had x cubed.
Yes.
And then this one, it has x minus 2.
Yes.
Now, if you check here, what has changed? Instead of x, they put x minus 2.
Yes.
Now, what does this mean, basically? It means they just took the graph and then shifted it 2 units to the right.
Okay.
So with that being known, we're going to tell them, okay, from here, it means with everywhere they saw x, they simply just put x minus 2. Okay?
Yes.
Yeah, this was for f of x. For f of x, we got x is equaling to
1
and x is equaling to 4.
Yes.
Now, if we can call this one g of x, we can tell them for g of x, then it means which when you are solving, instead of having x, agree here you're supposed to have x is equaling to 1.
Yes.
But for this g of x, we're going to have x minus 2 is equaling to 1. Because everywhere we see x now, we're replacing it with what? With x minus 2.
Yes.
And then we're going to say x minus or x minus 2
okay.
is going to be equal to 4.
Yeah.
And then if we transpose that to the other side, we say we have 2, which is negative, it goes to the other side, it becomes positive. Right?
Yes.
It says x is going to be equal to what? 2, 3.
Yes, x is going to be equal to 3.
Or if we transpose the 2 plus 4, it gives us what?
It gives us 6.
X is going to be equal to what?
X is equal to 6.
Okay, remember guys, hence or otherwise, it means good to use whatever it is that you've already done. So we're going to play the song. Let's play the song.
Before we play the song, if you think Mr. did what he promised to do, speaking slow, comment did it. And then if he didn't, comment he did not.
Okay, yeah, guys, I'm trying to speak slower these days, but I have a feeling that learners are the ones who are listening slow. I'm not speaking fast. Now you have a disability. You are listening slow.
Okay.
So let's go to the song.
Let's drop the beat on how to sketch the graph, lock in the inflection, and master the power of hence. 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 When you draw that cubic curve across the grid, make sure all the vital coordinates are unhid. Find the y-intercepts where x is zeroed out. What the root's about. Plot your turning points, label every single pair. Show the maximum and minimum, make them clearly there. And label your axes, don't leave them bare and cold. Let the story of the function be accurately told.
Marking breakdown. Based on the CAPS marking guidelines for a typical 2-mark, hence, or otherwise, question, here is the audit of your work. Step, line of working. Assessment. Mark allocation. Line 1, x2, cubed 6, x2, squared plus 9, x2, 4 equals 0. Standard form correctly established. Line 2 and 3 to 0 equals x cubed 6x squared plus 9x4, right arrow x equals 1, text, or, x equals 4. Implicitly used the roots from a previous question. Notation error present, see feedback. Line 4, x2 equals 1, text, or, x2 equals 4. Correct method. Equating the new argument to the previous roots. 1, m, line 5, x equals 3, text, or, x equals 6. Both final values for x are perfectly correct. 1, a, total marks awarded. 2 halves. Corrective feedback and CAPS compliance. While you scored full marks for reaching the correct final destination, we need to address a critical formal notation flaw in your working that could cost you marks in a stricter marking center, especially for method or notation penalties. The logical flaw, lines 2 and 3, you wrote 0 equals x cubed 6x squared plus 9x4 and solved for x. However, x is already defined in the original equation as the variable inside the bracket, x2. By rewriting the equation using the same variable x to represent the entire bracket, you created a mathematically invalid statement. X cannot simultaneously be x and x2. Formal terminology. When replacing a complex expression with a simpler one to use previous results, you must use a formal substitution statement, such as, let k equals x2. Socratic question for reflection. If x is already the specific variable we are solving for, what happens to the logic of your proof if you redefine x halfway through? How could you rewrite lines 1 to 3 using a dummy variable, like k or p, to make your substitution mathematically airtight? Coach's summary. What you did well. Excellent exam technique. You perfectly recognized the, hence, trigger word. Instead of expanding those horrendous brackets, which is a classic trap, you saw the structural link to the underlying cubic polynomial. That is top-tier mathematical insight. Area for improvement. Protect your marks by tightening up your notation. Never recycle the same variable during a substitution step. Always introduce a distinct temporary variable, e.g., let k equals x2, to maintain absolute mathematical correctness before swapping back to your original variable at the end.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your